Some of us are desperate to know the answer. Others may not think of anything worse. Welcome to America Infor-mate. If you're new here, please don't forget to subscribe and hit the notifications bell, so you don't miss out on any of our upcoming America's Gists. But for those who want a glimpse into their future to find out how old their bodies are, there's no need to look any further. Companies are increasingly trying to solve the puzzle for you. Biological age tests, featured on the latest season of Keeping Up with the Kardashians, can theoretically distinguish between your chronic age and your biological age. The former indicates how many years you have lived, while the latter is an estimate of your body's deterioration based on precise markers on your DNA. But new research suggests they may not be as accurate as initially thought in determining true biological age. The U.S. scientists who conducted the study warned that their findings have important implications for the interpretation of commercial biological age tests. It will help to improve their sincerity and usefulness for the future. Epigenetics is a well-established field, with dozens of companies producing their own saliva and blood clot tests. But questions have been raised about whether epigenetics itself can be used to recommend lifestyle changes. The traditional view of aging is that it is caused by a slow accumulation of damage at the cellular level. Just like a car, parts of us break or wear out. It can be difficult to put a number on this. This is where the epigenetic clock test comes into play. They cost between £150 and £300 on average, and they measure so-called DNA methylation levels. This is how special molecules, called methyl groups, stick to the DNA in your cells. It has been described as being like a barnacle that attaches to the hull of a ship and slows down its speed. In this study, researchers at Harvard University evaluated how stem cells within tissues or organs affect their epigenetic clock. Tests conducted on mice showed that it differs according to different parts of the body, as stem cells in skeletal muscle, the trachea, and even the blood proved to have a shorter lifespan than more mature cells. In comparison, stem cells had a similar epigenetic lifespan to mature cells in the skin and intestine. Muscle and blood cells that undergo abundant age-related changes record a distinct genetic age from bulk tissue, the researchers wrote in the journal Stem Cell Reports. Other experiments also showed that the epigenetic